Okay, moving on to example 4, we're going to find the inverse of f of x equals x squared plus 7. So our first step is to change that to y equals. Second step is to switch your x and y. And then we're going to solve that for y. So you would subtract 7 from both sides. So we're going to have x minus 7 on the left and y squared on the right. So then if we want y by itself to undo the square, we would do the square root. Except remember, when we take the square root of a number, it's really a positive and a negative solution. So that's going to leave us plus or minus the square root of x minus 7 equals y. Last step is to change that y to inverse notation. So we have plus or minus the square root of x minus 7. So then it asks us to find the inverse of 8. So again, if you notice, the 8 replaces the x. That's exactly what you're going to do in the function. You're going to replace that x with the 8. So that's going to give us plus or minus the square root of 1, and the square root of 1 is 1. So your two solutions are plus or minus 1. Example 5, we're going to find the inverse of x minus 6 squared. So in this function, this is a quadratic. Nothing was in parentheses. We still have a quadratic, but it's set up a little different. So it's going to look differently when we solve it. So I wanted to try to work one of each with you. So there's first step y. Switch your x and y. Again, we want to get rid of the square, so we're going to take the square root. So that's going to leave us plus or minus the square root of x equals, square root cancels the square, so we have y minus 6. So you're going to add 6 to both sides. So just be careful when you write this, that 6 doesn't get under the radical. And we could even change that around, but I think you're able to tell that it's not. Last step, inverse notation. And then it asks for the inverse of 9. So we're going to substitute 9 in for x. So you have the square root of 9. You have the square root of 9 is 3. So you have plus or minus 3 plus 6. So again, that's two different values. That's really positive 3 plus 6, which would equal 9. And then you have negative 3 plus 6, which would equal 3. Okay. So our last example is example 6, which is x plus 3 over x minus 2. I'm not sure if you can see that's a minus, but it is. And we're going to find the inverse of this function. So y equals x plus 3 over x minus 2. So that was step 1. Now, switching your x and y. You're going to replace both of these x's with a y. So you're going to have x equals y plus 3, y minus 2. Okay, so for me, the easiest way to solve this is to cross multiply. So I'm just going to put a 1 under that. And I'm going to cross multiply here and get x times y minus 2 equals, and then we're going to cross multiply here and get y plus 3. So then we want to distribute here. So you're going to get xy minus 2x equals y plus 3. So you're going to remember your end goal here. Your end goal is to solve this for y. Well, I've got y's on two different sides of my equations. So I need to move all the y's to one side and get those together. And I'm going to move this 2x over here. So it's kind of going to be like a little crisscross. We're going to move this y to this side, and I'm going to move this 2x to this side. So you're going to have xy. If I've got positive y here and I move it over, it's going to say minus y. If I'm going to move this negative 2x to this side, it's going to say positive 2x. Okay? So now I can factor this y out and have x minus 1. Remember, your goal is to get it by itself, so we can divide by this whole piece. So you've got y equals 2x plus 3 over x minus 1, because those are going to cancel out. And then last step, rewrite it. Okay? So there's 4 your turns here. This could just be some extra practice for you guys if you want to try those on your own, and we can discuss these at the beginning of class if you have questions on those.